All right, so we are on the last shape of our conic sections. What happens if you take a two-sided cone and slice it long ways? So we're going to go into hyperbolas, and I can see by the graph that many people have already moved into hyperbolas, but we're going to do this video for people who have not. But before we go further into this IXL, I would like to point you to this page that is linked. This is the Purple Math Introduction to Hyperbolas, which, as it says, don't come up very often. But I found out that they do actually, the shape of like the smokestack on a power plant. See the big things on a power plant that look like this, kind of look like that. Hopefully they don't look exactly like that. That's a hyperboloid, and it's a hyperboloid because it's rotated in 3 dimensions, right? It's not just a two-dimensional shape, but that's a hyperbola. So evidently it's a very material efficient and strong way to build any sort of chimney. And of course, the point of a chimney is to use the physics of the less dense, warmer gases to draw them out and exhaust them into the atmosphere. So there must be some good qualities about that. I'm looking at it and I'm thinking it's going to actually accelerate the gases as they go through this narrow chamber. So it's going to have a good drawing effect there. But that's it. Okay, so what we're looking at is hyperbolas. And this is the thing that you really need to center on it. And for myself, I find hyperbolas the least intuitive. I really have to like stop and concentrate to get hyperbola stuff right. And when I was messing with IXLs, it's very clear that I had to just keep notes and do things like in writing and keep things straight. Okay, so we have hyperbolas are very similar. The equation for hyperbola is very similar to the equation for an ellipse. In fact, it almost looks like an ellipse that you've cut in half and swung outward instead. It's obviously not quite. You can tell by looking. But the equation is very similar. It's going to be x minus h squared over a squared. Now it's going to be minus instead of plus. Y minus k squared over b squared equals 1. So that is for the ellipse that is showing. And there are also ellipses that are, you can draw them in any orientation you want, but we're only doing vertical and horizontal ellipses. So if it's going to be up and down instead of left and right, then it's going to be the y squared term over a squared minus the x squared term over b squared, like that, right? All right, so, and in this instance, the a is always going to be under the first term. So the a is always going to be this piece right there. So if you have a vertically an up and down instead of a left and right hyperbola, then the a will be on the y-axis. So that's why the a stays in the front position the whole time, because it's something minus something. Of course, when you have plus, it doesn't matter what order they're in. But when you have minus, it certainly does matter what order they are in. So let me give you a couple more things. And what I really want to do is talk you through an understanding of parabolas, because they're cool. I mean, excuse me, ellipses. I like parabolas and ellipses, and I just said ellipses instead of hyperbolas. I shouldn't make these videos at the end of the day. Okay, so you can see this box here, right? And the first thing I would point out to you is that the box is made of two parallel line segments, obviously. And one line is the line that is drawn tangent to the curve. Wow, that's not even close to straight, is it? Tangent to the curve at the vertex. So hyperbolas have foci. The green is this is the foci. There's a focus here, and there's a focus here. I'm just going to see if that's somebody trying to get into my room real quick here. In case, I don't think it is. I don't think anyone's showing up. But, nope. Okay. So there's a focus there and there. Then, of course, I just already said it. There's a vertex here and a vertex there. And there is a center right there. That's the center. And that is H, comma, K for X and Y, that makes it nice, right? At least they kept that consistent. So those are kind of the parts that we have. And now I'm going to erase that. And what we're going to do is we're going to notice something here. And we're going to go back to this thing. There's a line drawn tangent to the curve right at the vertex, right there, right? And so what we're looking to figure out is where this A, and how do we know that has a line? It has to be exactly at that vertex, right? But then there's this other line right here, right? It goes like this. How do we know where to draw that line? So we get that little box, because that little box is what gives us A and B, and then C is the distance from the center to the focus. So how do we get that box? That's the question. And the answer is asymptotes. And you may or may not remember that an asymptote is a line. It's an imaginary line that some sort of mathematical function or equation or graph approaches but never touches. So you can have like a graph that looks like this, and it goes down there, and it gets closer and closer and closer to, let's just say y equals -2, but it never touches it. It just approaches it. That's an asymptote. A line that the thing you're graphing never touches, it only approaches. So that's how we're going to find, what we have to do is find the asymptotes of this function. And those will tell us where the corners of that box belong. Because the asymptotes are going to be, oops. Oh, I missed that horribly. Where's the undo button? It doesn't exist. Those are going to be the asymptotes, like that, right? So you can see, and this is what I'm trying to show you, is this point right there. The red line, the one that is the tangent to the curve right at the vertex, that's a line we know where to put because we can see the graph. And then the asymptote is a line we know where to put because that'll be built into the equation. So where the asymptote intersects the line tangent to the vertex there, where those two intersect, that's where you draw this line right there. And so you have, you can't see any of it now. All right, so that's how you get the B and the A and the C. And so I'm going to put the A and B and C on here. So here, this is going to be the B distance, right? You can see that. And this is going to be the A distance right there. And guess what the C distance is? Yep, you got it. I'm sure probably that's going to be the C distance. So this is going to be, that's the B distance, that's the A distance, and that's the C distance. So you're going to have to be aware of that change in labeling, because remember, for the ellipse, we didn't use those letters. It was b squared plus c squared equals a squared. If with the hyperbola, it's a squared plus b squared equals c squared, which is what we want, right? I mean, who cares what we want, right? But that's what that's the labeling for the Pythagorean theorem that we are used to. So we have in a hyperbola, we have two vertices, which are right there and right there. We have two foci, there's one and there's one. And we have the center, which is that. And then we have our asymptotes that kind of define where those curves are going to go. So that's kind of the basic parts of the hyperbola. And you know what? Let me do one more thing. We're going to have to know how to remember how to make the equation for a line. Okay, so let's just take this asymptote. Let's see if I can draw that reasonably well. I think that's reasonably well. All right, so you might have to find the equation for that asymptote. And you could do it in point slope format or y-intercept format. Either one, they're going to ask you for point slope, at least in the beginning. And if I'm going to just refresh your memory here, y minus y1 equals m x minus x1, where x1 and y1 are any point, x1 comma y1 is any point, because it'll all work out the same, and m is the slope. So now we got to figure out, so to get the slope, you have to have 2 points. And if you remember from any two points will define a line. So we're going to pick 2 points. And I could pick 0, 0. That would be totally legit. I'm not going to do it just for the sake of illustration, but I could. So there's a point, and there's a point. And this point is going to be 3, 2. And this point is going to be 6, 4. All right. So now we got to get the slope. And if you remember, the slope of something is the rise over the run. Rise over run, which is another way of saying the change in y over the change in x, which you would find out by subtracting the first y from the second y. So we go y2 minus y1 and x2 minus x1. And it doesn't really matter which points you pick. You just got to get it going the right direction. You want to use the y2 as a more rightward point, and xy as the more right. The second point, x2, y2, should be the more rightward point. Y2, y1, x1. What am I doing? And there's no eraser. Oh! Okay. So anyway, we're gonna do. So this is gonna be 6. That's x. That's y2. No, that's shoot. I really wish there was an eraser. Okay. So y2. Y is 4 minus y1 is 2 over x1. X2 is 2 minus 1. X2 is 6 minus 3. Okay, so this is going to be point. This is point 2 over here, and this is point 1. So it's y2 minus y1 on top, and x2 minus x1 on the bottom. So now we have a slope. 4 minus 2 is 2, and 6 minus 3 is 3. So that is our slope right there. So m equals 2/3. And so now the equation for this line, we can just go ahead and use either one of those points. The equation for this particular asymptote is going to be y, and I'll just pick the first point, y, jeez Louise. This is how bad, that's why I buy erasable pens, you know? So y minus, and we'll just use the first point, y1 is 2, equals the slope, 2/3. And then the second point, which is x minus 3. I am really, these videos get goofier and goofier. So that's the equation for that line. Now, what about the asymptote that goes opposite? What about that one? Well, we'll pick a point, and we'll go like that. Okay, so there's our point, and what point is that? That's going to be 3 comma -2, right? That's the point. And the slope is the negative of the other slope. So that makes it pretty easy. So this one is going to be y minus, and then the y coordinate of a point on the line, -2, equals m. Now it's the negative version of the slope, 2/3 x minus 3. And that's the equation of that one. So there you go. That's kind of everything right there. And now I think we have enough to be going on with to go over to IXL and at least get a couple started. I tend to ramble on these videos a little bit. Apologize for that. All right, so here we go. This graph shows a hyperbola. What are its vertices? The vertices are the places right there where the two curves are closest to each other. They are also where their extremes are. So if you were going to find A, B, and C, where would you find them? Well, here's our, those are already there, right? The asymptotes are already there. We've got our little box there, right? And notice I'm drawing the box right where the asymptote intersects the line tangent to the curve at the vertex. So these points right there become very important in different things too, in terms of calculating stuff. So anyway, I'm just showing you that kind of stuff on this graph. But what was it actually asking? What are its vertices? Okay, so the vertices are going to be, you already know where they are, I'm sure. Right there and right there. So the vertices are going to be 0, 2, and 0, -2. All right, let's erase whatever's left from that. This graph shows a hyperbola. What is the length of its transverse axis? Okay, so the transverse, when you traverse something, you go from one place to another. So the transverse axis is 2a. It's the distance. So a is the distance from the vertex to the center, right? So a is this distance right here. And the transverse axis goes from one, hey, I changed colors, goes from one vertex to the other vertex. That's the transverse axis. So the transverse axis, and this will be important later because you'll be finding A or whatever, and then you'll have to find the length of the axis or whatever. The transverse axis equals 2a. There's another thing called the conjugate axis, and I'm just going to talk about that for a minute. So remember where our little box goes, right? Here's the line tangent to the graph at the vertex. So the asymptote crosses right there and right there, right? So there's our little box that sort of helps us see everything. And then the conjugate axis. Do you remember the conjugate from like finding the complex conjugate of complex numbers or whatever? So it's like the partner. You can think of it like that. The partner is the conjugate, right? So the transverse axis is the one that traverses, walks across from one vertex to the other. The conjugate axis is this piece right here. That's called the conjugate. And that's B in that little piece right there, you remember from before, is B. And so the conjugate axis is going to be 2 times B. All right, so now we need to find the length of the transverse axis. So I'm going to clear everything, and then we're going to go here and we'll look, and the transverse axis is right there. And it goes that's 4, and we'll subtract this one, minus -4. So the length of the transverse axis is 8, and A would equal 4 on this hyperbola. And then we already found this one. So if we had to find B, that would be 2. And then we would have H and K, right? H, comma, K is the center. So H would equal 0, and K would equal 0. And now you know an awful lot about this. All right, so we'll clear the screen again, and we'll just go back and put in the length of the transverse axis as 8. All right, so here we go. Let's look at this again. There's your transverse axis right here, right? And then you got darn. There's your line, right, like that. Right, like that. And that intersects the asymptotes right there and right there. So our conjugate axis is this piece right here, right? And that goes from, let's see, so that's y equals -3 down there, and that's 3. So we'll go 3 minus, we'll go the top one minus the bottom one. That's going to equal 6. So that's the length of the transverse axis, is 6. All right. Let's see, make sure to clear everything. Okay, what is its center? Well, its center is right where it is centered. It's right where those two asymptotes cross. That's one way to look at it. The center is where the asymptotes cross. The center is also halfway between the line that goes through the two vertices. It's also halfway between the line that goes through the two foci, whatever those are. I don't know exactly where they are. They're going to be somewhere like out there, right? So the center is going to be halfway through. It's going to be halfway through. It's going to be half the distance between the foci, or half the distance between the vertices. And just to recall it to your mind, the distance from the focus to the center is C. This distance is A right there. And then we're going to draw those lines again. Right there. And right there. And right there. And right there. So now we have a B distance. A is always this one. Doesn't matter whether it's longer or shorter. It can be either one. And this distance is our B. Right there. And it so happens that C right there, this C distance right there, and I know I said this before, I'm just going to say it again. That C distance right there just happens to match that C distance right there. So you can use the Pythagorean theorem to solve for A, B, or C as needed. All right, well, I don't even know what the question was. What was the question? Oh, what's the center? 0, 0. What is the length of the transverse axis? Again, the transverse axis, that's the one from between one vertex to the other. So that is 3, and that's at -3. So 3, and I know you don't have. I know I don't have to be writing out 3 minus -3 equals 6. But what if you get some crazy decimal, or you don't have a graphic thing in front of you, and all you know is the numbers from the vertices or the foci or whatever? Then you're going to have to figure out it mathematically. Anyway, 6, right? 6. What's the other one called? The conjugate axis. Should we draw the box again? Let's draw the box. So there's our A, there's our B, and then that is C, and that is also C, wherever that focus is. All right, so here, there we go. Oh, I gotta go back to that. Oh, there we go. Okay. What's the length of its conjugate axis? Okay, so the conjugate axis, remember, is not the it's not the other axis. Okay, so there's the center. That's the main axis. Now we'll draw these little lines. Ooh, gosh, that's a hard line to draw straight because I think it's an anatomy thing. There, and then there, like that, right? And now we see where the intersection is the transverse axis and the conjugate axis. It's asking for the conjugate axis, right? So that's what we had to find, is this piece right there. So that's going to be your A, that's going to be your B, that's going to be your C, which also happens to match that. That focus is going to be way out here somewhere. Anyway, so that's going to be your, that's a B, that's a C. Okay. Anyway, now we're looking for the conjugate axis, right? So this is up at y equals 6. This is down at y equal, did I get that right? Oh, look at that. I drew it in the wrong place. You probably saw that. It's right there, isn't it? It's right there. So this is at 5, this is at -5. And it's not always going to be right on one of the axes either, right? So that's 10. You know that. Or length of the conjugate axis, 10. Oops, 10. Oh yeah, there we go. All right. What are its vertices? Its vertices are right there and there. So they're 2, 0 and -2, 0, right? Doesn't matter which one you put them in. All right, clear that. What is its center? Oh, there we go. Now we got to look for the center. The center you can find, it's either where the asymptotes intersect, or it's halfway between the two vertices, or where the foci, probably more like up there, where the foci on there, it would be halfway between those, but we can just read it right off there, right? So it's 0, -2. 0, -2. Right? See, now it's not drawing out for us, is it? What are the asymptotes? So now we gotta go back and try to remember everything. Okay, so first of all, let's look at this. Let's take a little time and look at this. The first thing we notice is this is a y minus x, not an x minus y. So that means it's going to be an up and down hyperbola instead of a left and right hyperbola. All right, so boy, can I complain just one more time about not having an eraser? All right, so this is going to be, that is a squared, and that is b squared right there. So we already know, actually, so just to list the things we know, we know a equals what? It's the square root of 36, so that equals 6. And b, and remember, in this one, a is always the front position because it's a minus, so you have to have things in the right order. And a and b can, it doesn't matter which one's bigger in this instance either. So b is going to be the square root of 64, so that's going to be 8. What is the center going to be? H and k, there's nothing up here. There's nothing here or here. So h is going to be 0 and k is going to be 0, right? Okay, so now we have kind of enough to get going. So let's, yeah, and I'm telling you, maybe your mind works better than mine, but I always have to graph it out. Okay, so the middle is 0, and then our a is going to be, and notice the a goes with the y in this one, right? That's what you got to look for. So the a is going to be 6. The distance and the center, right now the center is 0, 0. So we can just go 6 up and 6 down from 0. But that doesn't mean it's always going to be that, right? So there's 6. I'm going to call that 6 up, and I'm going to call that 6 down. And then the b is going to be 8 to the left and the right. So we'll put a b right there and a b right there. And what's it asking for? Well, it's asking for the lines, the equations for the asymptotes. Okay, so what do we have from these points? This is the b points are 8, 0 and negative 8, 0, right? And the a points are 6, 0. That was supposed to change color. 6, 0 and negative 6, 0. And those are going to tell us where the corners of the box are. And the corners of the box are going to give us the line that we need. Well, let's get another color here. How many different colors can I possibly use? All right, so there's the corner of our box right there, right? Our box goes there, and there, and there, and that should have gone through that point. We'll make it a really, there we go. All right, but anyway, you can see that this point here, what's this point here? That's going to be 8 over, it's going to be the x from here and the y from here. I mean, jeez. I wrote those wrong. Hopefully you all saw that before me. But I would like to point out to you that I did find my error before I clicked submit. And the reason I did it, in part anyways, is because I take my time and I write things out and I draw them out instead of trying to hold the whole thing in my head. So that point here, that's going to be 8, 6, right? And this point here is going to be 8, negative 6. And this point here is going to be what? Negative 8, 6. This point here is going to be negative 8, negative 6. And now it's pretty easy to get our line, right? In fact, we know the center is 0, 0, and we know the asymptotes intersect at the center, so we can actually use that. I'm gonna use this point right here, kind of as my point. So I'm gonna find the slope m is the change in y over the change in x. And that's going to be, the change in y is 6 minus, that's our y2. And for our y1, I'm going to use 0, comma 0 because that's easy. And you do not have to pick hard things when you're doing your own equations. Just pick the easiest things you can. That's going to be 6 over 8. But you know that it's supposed to be simplified. Now, if I put 6 over 8 in there, I'm going to get it wrong. So that's going to be 3 over 4, right? So there's our slope. And now I can say our equation is y minus, and then our y1 is 6 equals m, we just did it, 3/4 x minus, and our x1 is 8. And yes, I could have put any other point in there. In fact, I could have put 0, 0 in there. That would have even been easier. And yes, it would be completely correct to just go y equals 3/4, 3/4, 3 over 4x. Because that's using the 0, comma 0 as our point. In fact, I'm going to prove it to you. And so that's the positive slope for this one. And then the negative slope for this one is just going to be negative 3 over 4x. And now we're going to put those in. See if I've embarrassed myself or not. Y equals 3 over 4x. And y equals, oops, I don't want to do that yet. I want to put the negative in. There's a negative. Negative 3 over 4x. Does that all look good? Looks pretty good to me. Looks like a lot of colored scribbling too. All right, so that's good. And really, the properties of the hyperbola, if you push this thing all the way up into the mid-90s, you will be, that's a good practice, is what I'm saying, is if you can actually manipulate these equations and everything to the point where you can find all the properties, the other two will come easier. So I really would strongly encourage you to, do this way. Okay, so what do we know? H and K are 0 again, right? H equals 0, K equals 0. And then we know that A is 5, right? Because A is the square root of this. And we know that B is the square root of that. So B is going to be 12. And so what are the vertices of the hyperbola? So we'll graph it out. Oh, I stayed with this sort of fuchsia color. That's all right. Okay, so the center, H and K, is 0, 0. And we know it's a left and right because the X is the front term. So it's got to be a left and right. So the A is under here, right? And the A is 5. And the A is the distance from the center to the vertex. So we're going to go 5 here. That's 0, comma 0. And it's supposed to be a 5, but I got too caught up in what I was saying. So that's going to be 5. So that's obviously going to be 5, comma 0 for that vertex. And this is going to go 5 in this direction, which is going to be negative 5, comma 0. And that works no matter where the point is. You got to just go along the line, and it's the X line or the Y line. Holy cats! This is the longest video ever. Anyway, I'll probably put in 1 or 2 more things here, and then I will wrap this up. So that's going to be 5, 0, and negative 5, 0. All right, boom. And so you can see that if you just kind of graph it out, what's the center of that hyperbola? We need nothing for that because it's in the equation right there, right? The equation of a parabola is x minus h squared over a squared minus y minus k squared over b squared equals 1, where h comma k is the center. And there is no h and k. So it's 0, 0. What are the foci? Okay, so I'm going to do this one, and then we're going to be done with this video. Okay, so if you were waiting for this one, we're here now. All right, so first of all, we're going to get what we can out of this. Notice it is a up and down, not a left and right. So now we know h equals 0 and k equals 0, right? That makes it easy. And a equals what? Square root of 144 is 12. And b equals what? Square root of 81 is 9. All right. So now we're going to take a little graphing thing here. And we're going to put the center, right, in the center. And our a is going to be 12. A is on the y-axis, right? Because it's always the first one. So we're starting at 0 and we're going up 12. And down 12. So this particular point right there is what? That is 0, comma 12. And this particular point here is 0, comma negative 12, right? But those are not the foci, are they? Those are the vertices. But that is our A, right? And now what's our B? It's 9. So we're going to take our B and we're going to start at the middle and we're going to go 9 like this or so, something approximately like that. And that's going to be 9 comma 0. And then we're going to go 9 in the other direction. And that's going to be something like this, negative 9 comma 0. And now we got quite a bit of information, don't we? Because that's our B. And what do we need? We want the C, right? And do you remember what the C? The C is the distance from the center to the focus, right? So it's going to be somewhere up here. And this thing is going to look, who cares exactly? Something like that, right? And C is the distance, is this distance right there. That's C, but it's also this distance right there, which is super handy for us, isn't it? All right, so now we're going to have the Pythagorean theorem, a squared plus b squared equals c squared. And we don't even have to square those, do we? Because they are already squared in the equation, right? So it's going to be 144 plus 81 equals c squared. And now I'm going to have to grab my calculator real quick because I can't even remember names at this late in the day. So we're going to go 144 plus 81 is going to equal 225. So then we're going to get 225 equals c squared. And then we're going to go the square root of 225. And I'm just doing this long ways so you can see it. Square root of c squared is just c, and the square root of 225 is what? 25, right? Nope. It is, I think I checked that, huh? 15. So 15 equals C. So now we're looking for 2 points that are 15 away from the center, right? C equals 15. And the center is 0, comma 0. So this is going to be what? It's going to be, this one's going to be 0, comma 15. And then there's going to be another one right down there. It's going to be 0, comma negative 15, right? And that's the way that's going to go. And then there's a thing down there too. That should have gone through that point. So it's going to be 0, comma 15, 0, comma negative 15, and that's going to be the end of this video. Are you going to wait with me to see if I got it right, or if I have to figure out what I did wrong? All right. So, I really, honestly, I think that with the amount of stuff we've done, you can figure everything else out, because you can see it's just all the A and the B and the C, and then you can find the transverse, just the vocabulary refresher at this point. This is the transverse axis. It's 2A, and this is the conjugate axis. That's what this particular problem is asking for. And that is 2 times B. And I think that will take you everywhere you need to go. So if you're still with me, thanks for watching. This was done without a live studio audience. Bye-bye.